Yo, 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 what's up, what's up, what's up? Welcome back. Today we're working on my terminal emulator, Termi. And it looks like we've been at this for about like maybe almost a month now, like 3 weeks, somewhere around there. And we're at a point where we have like a fairly functional terminal emulator, right? So I can say like, got bash running, I can run ls, I can run like git log, and I can like resize. I can like scroll in here and I start seeing something, right? There's like colors, there's bold, there's like font, probably like font effects, whatever. There's like, we've implemented kind of like, we're going like one by one, working through things that like we want that don't work and slowly adding them. So there's a lot that isn't implemented. Like there's a lot of stuff that isn't implemented, but we're at the point where we have like, something kind of reasonable. And today I wanted to work on building out like a replay system for this. So the way this works right now is we have like my program, Termi, and he calls this like Linux syscall to basically spawn like a file descriptor. Boom, 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 file descriptor. And this guy goes into the kernel. Or I guess the file descriptor, I guess is, I don't know if you should draw it in the kernel or out of the kernel. It's like, I guess kind of like in kernel space, I guess. And he talks to like a TTY driver, where TTY is something, I can't ever remember what it stands for, but it's like Linux's abstraction around like terminal things, right? And then this guy talks to bash, kind of, through like the same file descriptor, kind of. So you have termi and we have like bash. And then bash will spawn like, he'll spawn like less and like git, whatever, right? He's gonna like spawn programs. And so the way that this is like set up right now is that like kind of like this is the only thing that I can do is I can like talk to this file descriptor. And then what will happen is bash will kind of like send like control characters and like text back here, right? So when I type like, if I go in here and I type like ASDF, that like sends an A as DF this way, which goes back over here to bash. And then bash goes like, oh, I saw that ASDF and I'll send it back this way and back this way. And then it gets displayed. So that's kind of like what's going on. And what I want to do is I want to debug some like weird behavior that we're seeing. So if we look at here, if I start scrolling down, you'll notice that in some cases, the line is replaced instead of scrolling down. So I'm scrolling down now, 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 now. And there, in that situation, instead of scrolling to the next line, we see it replace the beginning of the line. Here, I'm going to press it right now. And you'll see like it kind of replaced this section here instead of doing something reasonable. And we took like a brief look at this yesterday. There's this like Linux utility called like script. And you can say like script, write everything that came out of the terminal to this like output log file and run the command git log, right? And then we can kind of try to reproduce that problem. There we go. There it is. And we can exit. And now it's we have a example of that sequence that like, what did like the program try to tell us to do? And we can look at that and we can say, oh, I don't have tab support. Fuck. And we can like, we see like these like sequences of characters that are kind of around here. I'm not sure exactly where it is. And we tried to like look at these briefly last stream and we couldn't really make sense of like, what the fuck is the terminal trying to do, right? Because there's all these types of like actions that you can do in the terminal. Hold on. So like, I have like my terminal, right? And I have like my cursor here. And so like when I send an A over and bash sends it back, what happens is like we move the cursor over by one, right? And then we write the A. But what happens in these like interactive applications is they might want to like replace this A with something. So they might like take the cursor and say, could you move it back over here, please? Then like fill up this with whatever I want to do. And then he might move the cursor down here and write some other stuff, right? There's like control codes that he can send us to basically do some actions. And we've been like slowly implementing these actions over time. And supposedly we've implemented all of the ones that Les cares about, but we must have implemented one wrong. And looking at like just this like raw output here, this is like very hard to parse. And I was thinking like, I need some way to debug this more sanely. And so what I was thinking is if we could maybe like record the bug, right? I can go git log and I can just like see what happens, right? I can go right here, there's a bug. And I could like record the sequences that come out of the program, like we did with that like script command. But we could like record it in a way that makes it replayable in Termi. So what I want to do is I want to take like this section here and kind of say, okay, so we can be backed by like a file descriptor that talks to bash, or we can have like a recording, and maybe we can like inject this recording here and cut out all of this stuff. We don't need any like actual interaction with bash. We know there's a bug, and we've bash is like, or less in this case, has like given us the sequence of commands that we need, the sequence of like letters that result in this bug happening. And so what I'm kind of thinking is you could have like some sort of like UI that looks like kind of like a video player, right? Where you can see, here are all of the characters that came in, and I want to go look at what happened right after this one and right after this one. Because what kind of happens right now is we get like snapshots of time, right? We see like, we pull this file descriptor down here and we say like, hey, is there any data? And he's going to send us like 100 bytes of data. And we're going to like parse all of that and like execute it all at once. And then at like some frame interval, we're going to like look at what the current state of the buffer is, which makes it kind of hard to diagnose. What I kind of want to see is I want to be able to step through character by character, see what each character does in Termi, and then we could maybe try to like build an intuition on one, what like is supposed, like what is actually happening, but two, maybe build an intuition on what the fuck the program's trying to do by pushing these bytes to us. And if we see something that doesn't make sense, then we can like start digging into that. And so the plan is kind of to first start with like the recording itself. How are we going to like store this data? The script command that we were just running is like almost what we want, except that the problem is that this doesn't track like terminal size, right? So if I resize the window, all of a sudden what like the program is going to do is completely different. And so what the program is outputting actually does depend on terminal size. Actually, I haven't 100% double check that. This does have a lines and columns thing here, but I'm pretty sure that if I resize during run, that doesn't get tracked. We should test that. So I'm just going to do some resizes here, and then hex dump the output log. Crash. Hex dump -c output log. Fuck, this is really long now. But I don't see anything in here that looks like a resize. Actually, we could probably test it a little bit more cleverly. We could just do script -o output.log and then do this and then exit. Okay, and we can check this again. Hex dump -c output log. And yeah, there's nothing in here that looks like it's telling us like the new size of the window. So our recording format needs to like support that. It needs to maybe support starting, not at the beginning of the command. We might want to like scope it to only a small section of what happens so that we can like record only the bug. So we're gonna have to figure that out. Then we're gonna have to like update our terminal emulator stuff so that it can be backed by like this recording or by like the normal bash file descriptor thing. And then maybe we'll do like a one-shot replay. So just like get into the same state again, make sure it looks the same. And then from there, we can start adding in like the video player UI thing. Yeah. I think that's all the context that's needed. So let's kind of just jump in. Okay. So I think probably where I like to start is like at one end of the problem, right? So there's either like you can start at like the user interface side or at the like data side. And I think in my head, it's going to make more sense for me to start at the user interface because I want just like, I know that's like a good entry point. So probably we're going to want to like, when we right click on the window, right, maybe we'll have like a little, hold on. Maybe we'll have like a little like tier, start recording, start and stop recording button. So we can like get into a state right before a bug, start recording, then end it after we hit the bug. So we'll have like a very small scope set of data. So, you know, you can just do like label, or is it selectable label? That sounds right. Selectable label. And what does this guy take in? If it's checked. So that's not really what we want. We want something that's more like a like label that when you hover on it, it's like a button. So I guess button is what we're looking for. We're just looking for a button. So it's UI button. And I think we put in text here. Yep. So we can just say start recording, and we'll put another one that's like stop recording. And what's that look like? What does that look like? Yeah, that's exactly what I wanted. So I can hit start and stop. Maybe it should be the same button. Who fucking cares? Doesn't really matter. And we'll say let if this thing was clicked, then we're going to have to go into our terminal emulator. So that's called terminal emulator here. I'll just say start recording. Sure. And maybe we'll get a little clever and we'll say that we'll have like a recording handle here. Maybe. That seems reasonable to me. We'll see. We'll see if this ends up making sense. I think it does. Because that kind of the reason I want to do it this way is it kind of makes it so that I can't be in an invalid state where I try to stop a recording that hasn't been started. If I do it this way, the only way to stop a recording is if I have a valid recording that has been started. So here I'll just do something like this. Hey, please start the recording. And for now, we're gonna have to go into here, this guy, and say, hey, we have this thing that is a recording handle. And actually, I don't really want this in this file. I probably want it to be in like source, terminal emulator, like recording RS. We'll maybe split it up. And where were we? Terminal emulator. I guess we're here. We want to make this pub struct recording handle. And then in here, we include this guy. So say mod recording. And in main, or GUI, I guess this needs to be a pub mod recording. Or we pub use recording handle. Maybe that makes more sense. Yeah, let's try that. Okay, sure. And then here, we can go back to the GUI and use terminal emulator recording handle. Cool. So his recording handle is going to start as none. And then we can even get a little clever here. And we can say, if self-recording handle is some, then we'll show the stop recording button. Else we'll show the start recording button. Yes. What's happening here? Somebody's not happy. Oh, yeah, like this. There we go. No method name start recording, so we gotta add that guy. So we'll say terminal emulator mod, and we'll have a function on the emulator. And we'll just add a pub function start recording, and he returns a recording handle. Cool. I guess we don't even have to write unimplemented. We can just give him the recording handle. And if we say stop recording, we just drop the handle. Perfect. Yeah, that's a good point. I can fold these if statements down. Cool. Cargo run. So now what we should see is on right click, there's like a start recording button that gets replaced with a stop recording button. Yeah, nice. Nice. Okay. So now what? When we start recording, we're gonna have to do something. I guess we're gonna have to like start writing some data to somewhere. Right? Like it's gonna have to go somewhere. So simple recording handle. Like, what is this guy gonna do? What is he going to do? So we're gonna have like a few states here, right? We're gonna have like initial state, and then we're gonna have like data added. And probably like window resize. Is that like all of the actions that can happen on this guy? Set window size, write data. We don't care about like data written to the file descriptor, like from us to bash, because bash will like tell us what it wants to display. If for this like recording thing, we're not re-simulating running the command. We're only like checking what the output of the command was. So nothing to worry about on write. On read, we get data, so we're gonna have to like store some data in the handle. And that's it, really. Yeah, nothing else can happen to us. So these are the things that matter. Okay, and so what we're gonna have to do is like the terminal emulator. He's gonna have to be like keeping track of like the current recording and like pushing stuff into it. So maybe it makes sense for this to not just be like have like a handle, but we can also have struct recorder. Yeah. And this guy, maybe we'll just like always be alive, right? He'll always be sitting in our terminal emulator. Okay. And that allows us to kind of unconditionally do things like on set window size. We can just say self recorder set window size. And then he can say, oh, okay, I will write those things down. That seems reasonable, maybe. So he has like function set win size, who takes in width and height. And he does some unknown thing. Some unknown thing. And when we get data, we're going to do the same shit. We're going to say, hey, recorder, could you please write the incoming data? Okay. Yep. And here we'll say function write. And he was going to take in self, maybe by mutable reference, maybe by not. We'll figure it out. And his incoming data. And maybe we don't call it incoming here. Maybe we just call it data. And we do some unknown thing. This guy takes self, maybe by mutable, maybe by immutable. These guys have to be public. And then down here, instead of this guy just returning a recording handle, he's going to have a function, start recording, who also, he's going to return the recording handle. Okay. Yep. And so now this guy says self recorder start recording. Okay. All right. Unimplemented recording handle. Cargo check. So we are close. We have to instantiate this guy. So he has to have some sort of new function that returns a recorder. And then over here, when we spawn our terminal emulator, we just say recorder is recorder. Recorder new. And this guy goes here, here. Where was he? He was down towards the bottom. It's like this spot here. Boom. Boom, boom. And then we need to use recorder. All right. Are we chilling? Everyone's happy. Okay. So now the question is like, what does like this interface look like? Who owns the fact that we are writing data? Probably the recorder struct. So he's going to have like some sort of like file. I guess maybe we won't even care that it's a file. It's just going to be like some type that implements write. And the reason to do this is because it'll make it easier to unit test. So we'll call it F for file, and he implements write. I don't know if you're supposed to. I don't think you need to put the trait bounds here. I think. We'll call it output is F. And then I think you say like impl F right here, recorder F like this. And then here we take in a thing, so output of F. Maybe not. I guess the recording, if we start and stop multiple recordings, they're going to go to multiple places. So this guy is maybe not going to be currently writing to anywhere. He might have a slot, he might not. And so probably when we start the recording, we should say, who are we going to write to? Which seems reasonable to me. So F is an F here. And we can say, so what's this API saying? We want to start recording. And in some cases, we might already be recording. So this guy can either return an option recording handle to say like, hey, here's the new one. Or he can return a recording handle that's like shared between multiple things. And probably shared makes sense. Maybe, I don't know. We'll figure it out. Maybe we'll do the rest of the stuff first and work on the handle after. So if output, if we already have an output, really there's nothing to do. Otherwise, though, we need to create a file to write to. We have the file already, so we just say self.output is equal to sum f, which means that this guy has to be mutable. And this guy needs to say f here, and this guy needs to be output none. Okay, cargo check. This guy is saying that he needs the type, which makes sense. Maybe we won't do this like file stuff for now. I do kind of want, I think I am going to want the genericism. Genericness. Genericnism. I think I'm gonna want it. So here when we say recorder, we'll just say that we have a recorder of like file. I don't know. Doesn't fucking matter. Well, we can fix this later. I guess, what are the chances that we don't want it to be buffered? Near zero, right? So we want like IO buff writer as well. And then here, can we just say buff writer? Or does he need to be a buff writer file like this? He might need to be like that. Gross. But livable, livable. Okay. So this guy needs to pass in a recording path. I guess maybe what makes sense is for the recorder to have like a directory that he writes into that's like maybe passed in by the user with a default value of like something sane. So we can say like recording dir, because like if you right click and you say start recording, like you don't want like a dialogue to like write to where you want to go. You just want it to like automatically start. Or you being me. I'm the only user of this thing, so I get to pick what I want. And I want a recording dir. So here we will use a path buff, and we will say the recording dir is a path buff, which means that in this scenario, now the recorder doesn't support just like arbitrary files, so we can just say file for now. Maybe we'll come back to the unit testing stuff later. We might find a way to do it, but maybe we just do the simple thing first and move up the ladder in complexity later. I should have started that way. So fuck these generics. Even though I just said like 10 seconds ago that I wanted them, I've changed my mind. Because now it's like slightly harder than I'm willing, and I don't want to anymore. Okay. So associated function here, blah, blah, blah. This guy needs an F, which he doesn't have, so we just say start recording. He'll automatically figure it out. And I guess we will need to find some name that's unique, that hasn't been used before. So I guess for now, we'll just say that we'll go self recording dir join, and we'll just say let I is equal to 0, and while we'll loop here, right? And we'll say, please add a number to this guy. So we'll just say I to string, right? And we'll say let candidate path is equal to this, and if candidate path exists, I plus equals 1, and continue. Else, I guess maybe we want like a little function for this. Function find recording path. Sure. He's going to take in the recording dir as a path, and he's going to return a path buff that is where we're going to write the recording to. And we just take this stuff, shove it in here. Womp, 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 womp. And then we say here, take it to self. So he's got the candidate path. If it exists, we continue. Else, we return candidate path. Boom. All right. And so then down here, we can say let recording path is equal to find recording path, boom, 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 and we pass in the recording dir, and then we say info recording to, and we write the file name, recording path display, boom, boom, boom. All right. And so then we have to open the file. So let recording file is equal to something. STFS, I guess it's just file open recording path. And we also wanted this guy to be a buff, right? So we can go zoom, zoom, zoom. Buff writer, STIO buff writer, boom, 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 boom. Easy peasy. We need path as well. Boom. Yep, so we have the recording file, and we need to open it as writable, so we actually need this, like, file. It's not file, it's FS, and it's, we also need open options. And so then we can say open options, new, write, true, create, true, truncate, true, and then open it. Boom. And for now, unwrap. Because I don't want to deal with errors yet. Eventually we'll have to, but for now, we can just pretend they don't exist. Okay. So we have a recording file. Who needs to be in a buff writer. Sees. Okay, and what we have to do is we have to actually store the initial state at this point. Right, so somewhere we have like pub, or maybe not public, we have like enum recording item. Okay, and he's going to have like a snapshot of like the current state. And so we'll say that like we have like a snapshot here, which means we need to say what the fuck is a snapshot. And that's going to be some sort of like combination of state here. So I guess we're going to have to keep it, we're going to have to look at our current parser state, right? So if somebody is like giving us like a sequence that turns into like some magic thing, right? So for example, if we want to move the cursor, we send like an escape code followed by an open brace, followed by like a number, and then like a letter. So this means like, hey, could you move the cursor back by 12 characters? This means go back. This means 12. This is like kind of like the like start flag. And so say that we start recording and we've received like this part. We need to write that down. Which means that our snapshot has to have the parser state. Which is essentially this guy. He's gonna have to have the... let's start here. Let's start with the parser state. How the fuck does this get piped in? Where does he get this info from? I guess the ANSI parser is going to have some function. Oopsies. Some function. Snapshot. Who takes in self and returns. What? Like himself? Like, it's essentially just this. Right? That's what we have to return. But the question becomes now, like this used to be some hidden thing. And now it's not. And is that okay? Right? Like, is like exposing implementation details here reasonable? It seems like kind of like wrong. It kind of like seems like it like limits us. We could do something like this guy defines the pub struct parser state. And he just like says what this is. That's like a waste. Why bother? So maybe we will just say for now, we can say he returns ANSI parser inner. And we will change this guy to say, we'll instead of calling this inner, we'll call this ANSI parser state. And sure. Yeah, nothing here seems crazy. And here we just say self.inner clone, which means this guy needs to be derive clone. And what's in the CSI parser? Yeah, that's fine. This can also just be derive clone. Derive clone. I guess that's reasonable. If we're trying to say, hey, we want to write down everything about your internal state and then reload it, being like, here's our internal state, that seems like reasonable, I guess. So this is going to be an ANSI parser state, which kind of means that like this guy kind of has to be public now. And then, like, this guy has to be kind of public now. Which is kind of fucking weird. But I guess maybe that's a side effect of this. Well, is there another way to do this? Say we didn't want to... Say we wanted us to own this in some way. Could we, like, take in the recorder and somehow like feed in our own current state to it in some way? Does that make more sense? So say we take in recorder and he's like, you know, he's just some recorder. We could say like recorder snapshot what? Self inner? Like, okay. Oh yeah, wait. I think that might be kind of reasonable. Yeah, I think this might actually be okay. So say let's take the concept of the recorder out of here. Just temporarily. And let's just say that this guy wanted to like write himself to a file and be able to load back from that later. Or write to a buffer and be able to load back from that later. We could have like impl from JSON or something on this guy and impl to JSON or something to this guy, right? And then we could just like serialize and deserialize them. And each component could be like in control of their own construction and like checkpointing, essentially. Well, what's the current state of the terminal? It's the buffer and its size. How do we get there is relevant for a snapshot. Well, I think the parser state actually is relevant. Because of this case where like somebody is sending us an escape code, like this guy, and they've sent us half of it, and then we start a recording. So like what comes in next depends on the current state of the parser. So we have to write that down. And I think that's like the more things we add, the more things that we're going to have to write down. That's what I suspect. And so it would be nice if we could like kind of distribute the like serialization logic so that each guy doesn't have to like expose things publicly. And so I think that'll work. So I guess what we have to do is we have to figure out like, well, what the fuck does it look like to serialize this guy? And I think for now, I'm going to pull in some dependencies. I know, a sin according to us, but I don't really want to write serialization and deserialization logic. I just want to use JSON because I usually start with JSON because everyone supports it in like the entire fucking world. And if I ever decide that it is not a good fit, it's easy to swap out later, right? We don't have to make like a lifelong decision here. But we can start. So srd JSON at 10114. Okay. So let's start by saying this guy implements serialize and deserialize. Alternatively, we disregard the snapshot function and implements recorders every single incoming byte. So I was thinking of that, except that I want to be able to like really scope in on the problem in the recording. I guess like if I record everything, you could argue that like I can just replay to that point. But I do think the snapshotting will make things easier. I do think that. I could be wrong, but I think it will. So here we can use srd, serialize, deserialize. And I think here you need to say that you want like features is equal to like, you want like derive here, I think. To say like, hey, I want these like macros to exist that basically let me do this shit. Derive, serialize, and deserialize. And this guy needs it too. Boom. And this guy needs it. Okay, so I think that's it. And so we can say, here, let's just say print line. Okay. srd JSON to, I don't remember. Let's just say toString right now. Pretty. And let's just kind of see what fucking happens. Cargo check. I guess this guy doesn't have to be debug. And then there's all sorts of stuff that doesn't work right now. So the recorder, this guy now takes in a recording path. So we'll say recordings into, and we'll put a fix me here. Do not record hard code recordings path. Okay, what's next? Start recording no longer takes an argument. Okay, and here we need to unwrap. Okay, and in the recording, this ANSI parser state goes away. Just while we figure this out. 66, this guy has invalid use after move, so we just put a little ampersand in front of him. And 599 in, where was that? That was terminal emulator mod. We look at $5.99, and we just put slap a little mute on this guy, and then he can borrow his mutable. Everyone's happy. Cool. Okay. So let's just see what happens if self ANSI, what's the parser? Snapshot. Let's just see what happens when we run that. Womp, 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 womp. Not implemented. Right. Right. Of course, we're gonna crash because it's not implemented. Okay, so now we start recording and we get a crap error on 64. So here we try to open the thing in the recording path because the recording dir doesn't exist. So we have to say recording dir. We have like stood fs create dir all of the recording dir unwrap, and we probably have to put a little ampersand on this guy. Give him another second. Womp womp. Start recording. Stop recording. Okay. Start recording. Stop recording. Okay. And so we're writing down the CSI parser state, which is good. Cool. Yeah, easy. So now the trick is, how do we like hook this up to the recorder? So maybe we have the recorder has like maybe not the recorder, the recording handle, right? Because we want to work on this particular recording. He's going to have a function that's like a snapshot item. And maybe he's going to take in like anything, like the name of the thing, and like its content. So here we can say like anything that can be serialized. I like that. So we can say item is anything that can be serialized. Yeah. And here we say S is serialize. And so we use Certi serialize. Okay. Okay. Pub. And I don't know if this has to be mutable, so we'll think about that. This guy is going to have to store something. So maybe he's in charge of the file. Okay. Which means that when I call this, I can just write to him. But then we have this other stuff where it's like, what about when these guys try to write to him? Do files have to be mutable to write to them? File. So like, I guess we have to like write the write trait, not format write, IO write. This guy does require mutable reference to self. Okay, so if I have like two places where I want to write for them, either I have to send it over to somewhere else, transfer the ownership, or have some sort of like shared state. There's also other parts to think about here of like what happens when this recording handle is dropped. He's going to close the file, and so like how does the recorder know that he's going to close the file? File does not need mute. Modprog rating with party of 6. Thanks for the raid. Appreciate it. File does not need mute, but because like hold on. Doesn't the write trait require mutable? stdio write is implemented for and file. That's legal? You can do that? So you implement... Hold on. I've never seen that before. You have piqued my curiosity. What is all this stuff? Do I care about any of this? No. Okay. Cargo init. Name test proj. Okay. oops, envim, main. So you're saying if I have like struct my thing, and I say use stood fs right, or stood io right, and if I want to say impl stood io or impl right for my thing, then we implement right, and we say like, I don't know, right buff hello world, right? Must implement IO right. Does buff not implement IO right? Oh, this is not the, sorry, this is not the buff, fuck. We're just gonna print line it. There we go. Print line hello world. So this thing needs a mutable reference, but since we're implementing for a reference, we have a mutable reference to a reference or something, and that like makes it okay. So here we write okay like this, and maybe we even write out the buffer. Stood stir from UTF-8 buff. Okay. I just want to see what happens. And maybe here we write okay buff len here like this. Boom. Okay. So you're saying, oh, not all trade. I need to implement flush as well. Okay. It just does nothing. I don't give a shit. So we're going to say let thing is equal to my thing. And you're saying that I can do thing right? Like this? Even though it's not mutable? No method thing, no method named right. So what if I do ampersand thing right like this? Wow, that works? What the fuck? I never knew that. Wow, okay. Wow, I didn't know that. Okay, because I've actually done a lot of times. I've like hacked shit where I've used unsafe to like discard this mutable requirement because I knew the thing underneath didn't need it when I could have just input fuck. That's so annoying. Okay, that's kind of cool. I didn't know that. Useful, useful, useful. That's neat. Okay, so that means does buff writer need mute? He might. Implementations. Impl write for buff writer. Okay. Impl write for buff writer. So I guess in this, if I'm buffered writing, then I actually do need a mutable reference. But if I am not buffered writing, then I don't. So let's just start there. Let's start there. So if I take like a shared reference to a file, maybe a thread, non-atomic shared reference, that seems fine. I think you must be the first person using Rust docs in light mode. I've never understood the fascination with dark mode, to be honest. I've never got it. Is it RC? With my Rust experience, I would discover by accident and not pay much attention to it. Okay, so this guy is going to have an RC file. This guy's going to have an option RC file. And that solves one problem. It solves the problem where from multiple places I can now write to that file, right? So I can say self file write all, and then I can serialize the thing. So I can say surdy JSON. I like that mode. It gives me a headache after a while. But like, okay, so isn't the sun, or just like outside on a cloudy day, just like a million times brighter than like a white screen in your room? Like, I just don't understand. Like, my lights are on. Like, so like, and the window's open. So like, isn't light mode like fine? Are people out here like programming in like the fucking pitch black? And like, I can kind of understand that. You're in a dark room. Your eyes are adjusted to all of like the dark stuff around you. You want to see like things that aren't the computer. But like, doesn't that suck? Like, imagine going outside. Like, but I every time I've tried to like sit in the dark on my computer, my head just hurts because I want to like see the rest of the room. I want to like see what's going on, and it's just like the brightness of the monitor. I guess it's the same thing that you're saying. It hurts I'm saying it hurts to look at the monitor when the lights are off, and you guys are saying it hurts to look at the monitor when the lights are off. We're kind of saying the same thing, except my solution is to turn on the lights, and your guys' solution is to cater all content on your entire computer to match the brightness of your room. I get it. Okay, I'm seeing it. I didn't think that people actually just sit in the dark. I thought that was like a meme. So, why? Why do you sit in the dark? Is it like, what? I guess like you like it better, but like why? I guess I shouldn't judge. Like that's surprising to me. Less distraction. I can see that. Okay, so serde JSON. He needs to write to the file, but he's not just writing blindly to the file. The file is going to be some sort of like array of things. So we're going to have to maybe say that the recording handle, maybe for now, just to like make my life easier, we're maybe going to stop thinking about the file for a second. And instead, just think about this as a array of recording items. So we'll say items is a vector of recording item. And so for recording item, we're going to have a snapshot, and he's going to have like the name of the item, the name of the snapshot, so string, as well as the data, which is going to be a string as well. Is that true? I guess this is actually going to be a serde JSON value. That sounds right. So we're going to take something in, we're going to serialize it to JSON, and then store it. Sure. Okay. So here we're going to say serde JSON to value the item. And then we're going to put that thing in. So we're going to self items push, and we're going to say recording item snapshot, and we're going to pass in push in the name and the data. Okay. And here, we're kind of saying that the name is going to be owned, so we take it as a string. Let the caller decide. And here, we can unwrap for now. I like how chat interaction increases by 500% when we start talking about themes. Yeah, there's some things that just like will always get people. That, tabs versus spaces. No, that's it. Those are the ones. Right, the real question is why dark terminal and light browser? I just use defaults, man. Oh, operating systems, yeah, that's another good one. Like, my terminal, I just, like, open it and it's dark, and then my browser, I open it and it's bright, and I just, like, don't think about it again after that. I don't know. Okay. So, here, that seems like a reasonable snapshot. So now the recording handle needs to actually... Interesting. So if there's recording in progress, I guess we want to return the like current handle. Ah, it's all coming together now. Yes. So here, if the handle is sum, we return a clone of it. So if let sum handle is equal to self handle, as ref, I think you have to say, you return handle clone, which means that this guy needs to implement clone. And we also need to make sure that the stuff inside is shared. So then we have like struct recording handle inner. You can tell I'm fucking deep in the sauce too when I'm talking, when it's like second nature for me to make a struct that has a single struct inside. Like this, like, you can tell I've been writing too much Rust when this just comes naturally to me. Okay, so now we need some sort of, like, arc mutex sync arc and mutex, sync mutex probably as well. You could argue that I don't need arc and mutex, but I don't really want to think about single thread versus multi-thread right now. On Ubuntu, default terminals like purple, can't have that. Yeah, the Ubuntu one does look weird, eh? I do actually change the default Ubuntu one. The purple gets yeah, the purple gets on my nerves. Okay. So this guy has this, which means that here, when we're pushing items, we have to say self dot. I actually say inner dot lock unwrap snapshot item. Yeah, that sounds right. And then we pass in the name of the item, and then all the code that we wrote before, this will go on the inner thing. So impl recording handle inner. Now he can be used as pub function, not pub, function snapshot item with the same signature. Womp womp. So this guy goes, boom, snapshot item. He takes mutable self, doesn't have to lock anything, pushes in the items. Boom, boom, boom. And so now this snapshot item is not mutable. We just lock the thing inside and we snapshot. Boom. Boom, boom, boom. Okay. We're close. We are close. Right, so the recording handle that I wrote down here has to be an option still, because we might not have recording in process. Progress. And this handle. And this is now some recording handle. Like this. Inner is a arc new mutex new recording handle inner. Where the items is empty. Jesus. All right. And then we return self handle clone wrap. Okay. All right. I think that all makes sense. We didn't actually use the recording file because this guy's not holding that. Maybe we just store the path for now. I don't know. We'll figure it out. Recording file. So this guy maybe takes in the path is recording path. And then, so the only piece that we're missing now is when the recording handle is dropped, we need it to automatically go away. Right, so the problem is that this guy's going to be holding a reference to it forever. And we don't want that. So maybe this guy should have like a weak reference to it. Oh, yeah, this is starting to come together. So maybe... Hold on. We can look at the Rust docs for arc. And there's a way to get a weak reference to this guy. Where does that come from? Downgrade. So maybe we just get rid of this, like, we get rid of this inner thing. No, we need the inner thing. So here, maybe we'll just say we have a weak sync. We have, fuck, my language server crashed. So where are we? This guy has a weak reference to a mutex to a recording handle inner. We'll just kind of bypass some of the abstractions here. He now will say let handle is equal to this. Maybe we'll call it handle inner, like this. Okay. So this is the arc mutex bullshit thing. Okay. Now the handle is going to be some handle arc downgrade handle inner. Okay. And then we construct a new recording handle Inner is handle inner. Yes. Okay. Okay. And now we just have to say here. Maybe we don't even need the option. Can you have a weak reference to if that wasn't constructed from an arc? Weak. Can you have like weak empty? Construct a weak without. Perfect. So we can drop the option. We can drop the option because if this guy doesn't, it's just double. Maybe this thing exists, but weak already kind of implies that the thing might not exist. And so now I can just say that this is weak new, and then I can say if let. Where's upgrade here? Upgrade, empty, upgrade, function, upgrade. Here we go. So if let sum handle is self-handle upgrade, then we just return the handle. But we have to say recording handle. All right, I think we got there. Inner is handle. Recording handle. Did we get there? Oh, I think we did. We're so close. We are so close. This guy doesn't have to write sum. Oh my god, we got there. Thank god. Cool. Rust doesn't feel quite ergonomic to me, but Cargo feels nice. Performance is good. Compiler errors are generally helpful. So it's quite high. What I would write in C, but really want built-in hash maps language pick list. Yeah, I think that's pretty reasonable. That's pretty. Yeah, I agree. I don't really know what ergonomic means. Do you mean like it hurts your hands to write? Like, I like the choices they make. But yeah, you're right. It is like a lot sometimes. Hurts my sanity to write. It definitely like forces you into doing things a certain way, which is annoying sometimes. Okay. So now we need to say what happens when we get write data and we write window size. What's a terminal emulator? Like this thing. You type into this, goes into the terminal emulator, goes into bash. It's like what's displaying the command line processes on your computer. Their history there is that they're called terminal emulators because there actually used to be physical terminals that were like connected to your computer. And we're basically like in like the 70s, we're basically like copying what they did back then, but like in a program, so that bash doesn't have to change since like in the last 60 years. Okay. So in our recorder now we have this like recording item that we can snapshot. And now we can say what? We also want to say that there's like a data and a window size. So the set window size thing is just going to take in a width and a height. And the write is just going to take in some like data. Which is evec u8, I guess. It's going to own it. Cool. Bash communicates through std and std out. Yeah, well, we can draw the little history of terminals goes further than computers. They hooked up electromagnetically controlled typewriters, telegraphs, and punch face tape readers first. Yeah, I did see that actually. Yeah, that's pretty cool. So in my mental model, we have like this is like a physical terminal. It's got a keyboard and a screen, right? You have like a computer. Which I guess may not have been a computer at this point in time. And there's like a wire, one going this way and one going that way. And you type, what happens is like, so you press the letter A here, an A goes into the computer processes it in some way, sends an A back, and then an A gets printed here and the cursor moves over. Essentially. And so like this guy is kind of like in control of like where characters get written as well as cursor control and stuff. But it's not serial anymore, right? Yeah, but like the abstraction's the same, right? So we have like in like the Linux driver, you have like this like TTY, and he like has like UART, and then there's also like file descriptor that talks to like emulator. And I shouldn't say it's not serial anymore because actually at like one of my previous jobs, I worked on like firmware for like embedded Linux devices, and in that case, like having like this UART was actually really nice. It's just instead of the UART going to like a physical terminal, the UART would go to like another computer's UART, who would then have like their TTY. It was kind of more like, yeah, the computer was still a terminal emulator, but he was getting the data over like the UART instead of like an in-house file descriptor. So still useful for sure. Okay, so now we can just say we have like other functions on here, and they're going to be like set win size, and it's going to be width usize, height usize, and right. All right, and this all is starting to make sense to me, I guess. I guess, do we need, like, these calls duplicated? Probably not. Probably not. Maybe it's, like, kind of nice too, but we could just say that the recorder, his only job is to start recordings. And then the terminal emulator can, like, hold onto the handle, and he can do this, like, set window size stuff. Okay. So here, set win size width height. And this is right, and he doesn't take in width height, he takes in some data. Okay. And that means that this guy just takes in data. And then we need to do the same thing here. Womp womp, copy paste, copy paste. Pipe in through. And now we have to do the same thing where we serialize these things. So we just push the... What is this pushing? This is pushing set win size of width and height. And this is pushing a right of data right. That's what we called it. And we just pass in data is data to vec or something. We'll come back to this. Okay. So now we have like a list of like things that have happened, and we need to like save them. So I guess we should maybe periodically save them, or we can, for now, we'll just save it once at the end. So we'll say impl drop for recording handle inner. Yep. And here, he's just going to say self path let f is equal self path open path stood fs write to self path, and we're going to write a serialized version of the contents. So we're going to say serd json to vec pretty self items or something. I don't know. Doesn't fucking matter. Let's just try that for a second, and we'll see if this goes anywhere. So here we're calling write on the wrong thing. So he's got to hold on to the recording handle. Okay. So when we start recording, we say that the handle is equal to sum self recorder start recording. Do we want to hold on to the handle here? Ugh. Not really. I don't really want to hold the handle here, because then we have like the same problem where it's like who's in control of dropping it. We want the UI to be the only person in control of dropping it, which means that the recorder does in fact need those write and read the write commands. So we have to propagate that function to one more spot. Fine. Fine, we'll do it. We'll do it that way. Fine. Boom. So this guy has the same functions with the same inputs, except I guess we could actually do it this way. So the recording handle lets us snapshot. Oh, whatever. It doesn't fucking matter. It really doesn't matter. So we can upgrade. We could have like some sort of like function upgrade handle, which returns an option of recording handle. Yep. And this just calls, I guess we don't need this. It's just self-handle upgrade. We can handle that ourselves. If let sum handle is equal to self handle upgrade, we just call handle set win size. That doesn't seem so bad. Oh, but we need to turn this into a recording. Oh, we need to turn this into a recording handle. Inner is inner set win size like this. Gross. Gross, gross, gross. But not the end of the world. So this is right data. All right, I'll live with that. That's not terrible. That's not terrible. Do we compile now? No, of course not. Why would we? Serialize not implemented for recording item. Okay. Which makes sense. So I think we can just say derive serialize and deserialize. Oops, not here on recording item here. Okay. Trait as ref u8 is not implemented for this like thing, so this is 2vec pretty. He uses an unwrap. Forgot that guy. And we don't have deserialize imported. All right. 32. These guys need to be mutable so that we can push to the vector. And path has type path buff, which does not implement copy. So here we put a little ampersand here. And now are we chilling? Nice. Okay, we are chilling. So now, if we've done everything right, we should be able to start recording. So maybe we should have like some sort of initial state. So maybe we'll say git log, right? Start recording, scroll down, hit the bug, stop recording. And then we see we wrote the recording. So we have recordings 1. And we have a bunch of set window sizes back to back. Womp, 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 womp. Oh, because we should actually only write them on change. So we can go back here. So somewhere, we already do this. Set win size. So here our recorder should only write if the size changed. And we can look at this again. Okay, so here we git log, start recording, hit down, hit down, hit down, hit down, hit down, hit down, hit down. There's a bug, stop recording. And now if we look at recordings 2, we have basically a bunch of data writes back to back, which looks good to me. You can kind of see how they come in groups too. Maybe like you don't need to, like they don't have to all be their own individual chunks. Right, we could say, you know, if, sorry, on this one, if self items back last mute. If the last thing was already a write, so if let sum recording item write data like this is equal to this guy, we push to that guy. So we say data.extend with the data. Otherwise, we do this. Okay. Does this guy have to be mute? And this guy has to be, oh, this, I see. So this is fuck. To insert, we'll call it. And that will make it. The names not collide. And change this to insert. Okay. Are we chilling? So now we should get one single write call until there's a resize, I think. Cargo run. Okay. Okay. So here we start recording. We write ASDF, 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 resize a few times, and then write ASDF, ASDF, ASDF again. And now we can see what the fuck happened there. So we saw some writes, then a set window size, and then some more writes. Then a subset window size, write, set window size, write, set window size, write. Because bash is like doing some shit in there too, which is pretty sick. We're getting close. We are missing the snapshots though. So we just have to make sure that everybody who needs to is snapshotting now. So maybe we go into our terminal mod, and when we start the recording, we like get the handle. And we start by saying recording handle snapshot item. And I guess how does this work? Maybe we pass in the recording handle to this parser snapshot function. So he inside would then say recording handle is a recording handle. Right? And then he would say recording handle snapshot item. And he would just put in his name, like ANSI parser. And self inner. Now the question is he who should own the name mapping, or should that be owned externally? In which case we could actually say this guy returns a impl serialize, and he could just return self.inner like this. Does that work? We have to specify the lifetime as well, so we can say, can we say like plus a, like this? Or unknown, I guess. How does this work? I think that's right. And then here we say snapshot. We say recording handle snapshot item ANSI parser, like this. And then return the recording handle. Does that all work? That's kind of nice. I like that. That doesn't feel awful. And so then we just have to start adding like snapshot methods to all of the guys that need to be snapshot. That's not bad at all. Not bad at all. Okay. So terminal buffer, he's gonna do the same thing. He's just gonna have a pub function snapshot, which returns an impl serialize and lifetime associated with myself. And we're going to use serde serialize deserialize. What's the order that I usually do this stuff? I don't know, whatever, it doesn't fucking matter. Doesn't fucking matter. And then we can just say, I guess we just derive serialize and deserialize, and we return ourselves. I don't really like that this trait gets like publicly associated with this. That kind of sucks. But we can live with it for now. That's fine. Yep, easy. Easy. What else needs to be snapshot? What else? We need to keep track of the format checker and our mode. So format checker is going to do the same shit. So he is going to say snapshot and return something that is serializable and associated with his own lifetime. And it's just going to be self color info. Easy. Easy. Use serde serialize. I guess we don't even need deserialize here yet. And here we need format tag to be serializable, which means terminal color needs to be serializable. All right. And now everything's happy. Everything's happy, which means that here in our terminal buffer, or not buffer, the terminal abstraction, we snapshot the format tags and format tracker. Let's call this format tracker here. Maybe we match the names of the variables. And then the last thing we need to do is serialize this guy. All right. So let's try it again. I think that should be all of the state that we need to reconstruct this guy. So let's start by doing something like git log, set up our repro case, or maybe it's like something like this, and we will find the line. So there's one. Oopsies. And we can just say start recording, down, 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 stop recording. Okay, and what we should end up with is we should end up with, oh fuck. I was trying to say debug render. There we go. Well, we should end up with something sane at the end there. Okay. So recordings 4. So we have snapshots for the parser, the terminal buffer, the format tracker, and deca mode. And then we have a write. And that's it. So does the terminal buffer, does he have his like size? He does. Sick. Sick. Okay. So I think we finished adding the start and stop recording feature. And now we're going to have to find a way to reload these things. So maybe we say add-u and git add source terminal emulator recording, git checkout whip branch, it already exists. That's fine, we can remove that. Update, refs, heads, whip, head, git checkout, whip, git status, git commit -m, whip, implement, add recorder. Okay, so now we have to like load from this thing. So I guess probably what that means is we're going to have a function here that's like pub function from recording. Okay. And he is going to take in a recording path and return a terminal emulator. We'll pretend it can't fail for now. And this guy is going to open the recording, and he is going to like parse each recording item, and depending on what it says, do something with it. So what does that mean? I guess we can't do this yet because we're going to get stuck on this, like the requirement on like a file descriptor, which is why this says update terminal emulator to allow different sources. But maybe we'll actually do that after. Let's start with the one-shot replay, and we'll just kind of hack around the file descriptor problem first. And we'll figure out what the rest means later, like what the correct interface is to support this. I think that like once we try it, we'll have a better idea of like what's required, and that will be helpful. Okay, so what are we gonna do? We're gonna open the recording. Surely. And we're going to try to deserialize it into a bunch of recording items. So we're going to say let recording is a vec of recording items. And he's going to be surd JSON from reader. And we're going to have from. Oh, you're going to look it up again. From slice. I guess we'll do from slice just to simplify the code here. And then do std fs read recording path. Because I'm too lazy to actually open the file and pass it around, etc., etc. I just don't want to deal with it. So let's do this. Easy. And then we'll just say for item in recording, match item. And if the item is a snapshot with a name and data, we're going to have to match the name. And we can say as name.borrow, so we get a string out of it. And then here, we're going to just look at all of our keys that we have. So it's parser, terminal buffer. These should be constants. Terminal buffer, format tracker, and decgum mode. Okay. In this case, the data is going to be a Boolean. Does this guy come out as like an option or what? Data as bool. Yeah, he does. So we'll unwrap for now. And we'll say, we're going to have to maybe construct, fuck, I don't know. Decgum mode is equal to, we'll make it mutable, and we'll say it's none initially. Then when we get it, we'll say it's sum. Decgum mode is equal to sum this thing, right? Boom. And for anything else, we just do nothing. Maybe we warn. Warn unexpected item name, and we maybe pass in the name even. Cool. No method borrow for string? Really? I thought that maybe it's as ref. As stir. That works for me. That works for me. They're complaining about set win size and right, so I'll just put these in here out now. Set win size, this is width and height, and data. Right, actually. And this guy is a field of data. Mismatch types, they expect us to return a terminal emulator, so at the end of all this, we're going to have to say terminal emulator, and we're going to have to like put in the data. So we're going to need to have a parser, a terminal buffer, and a format tracker, as well as cursor state, which I forgot to serialize before. Which means that this guy has to have cursor state. Do something, and we have to serialize the cursor state as well. We didn't do that. So this is cursor state, and we serialize the cursor state. Okay, which means cursor state needs a snapshot function. Impl cursor state, and he's going to need a function snapshot, who takes in himself and returns a serializable thing that's associated with his own lifetime, and we just derive serialize and deserialize on him. That seems simplest. And then we return ourselves. All right. Dude, I gotta try out Olama plugin for NeoVim. It's like, well, better, but FOSS. So that like FOSS stuff for these like giant ML models, if I remember correctly, Olama is one of those LLMs by like Google or Facebook or something. Olama. Who owns this? Is this recent? I can't remember. Oh, they host multiple IC. But like my understanding is that none of these are like truly open, right? Because like they're like open isn't like that you have the code to run the model, but like the real juice in these things is like the training process, and those aren't open, right? Because like you need like this like tons and tons of data that you just don't have. That's my understanding at least. But I mean, yeah, I guess I haven't really tried any of those like AI code completion tools. My gut says that I don't get them, but yeah, I would have to give it a shot. But like from my experience like trying with ChatGPT, it seems like I usually know what I want to write. And if I don't want to know what I want to write, it seems like an AI doesn't really help me. But to each their own, I guess. I can see the draw for some. Maybe I'm just acting like an old grumpy man, and I'm just like missing out on something cool because I'm not willing to try it. ChatGPT is less open. No, I get that. I'm just saying like usage-wise, even they don't seem very good. Is really more what I'm getting at. Like they just seem kind of worse than me doing it by myself. That's the impression I've got, anyways. Okay. So here we're going to have some sort of cursor state is going to be some sort of like JSON thing. And can we like, how does this work? This srd JSON thing, he makes a value, and this value probably implements serialize and deserialize. So we can deserialize from a JSON value to a known type. So we can just say from value here. Yeah, nice. Okay, so we can say cursor state equals some data data. Oh, maybe like the value type itself already has like a magic cast thing that it can do. Get, so this gets the item at that thing. Get mute is object as object, which object gives me like a map as array, blah, 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 stir as number, blah, blah, blah. Yeah, none of these really want. Okay, so we say like srd JSON from value, and we pass in the data, and we unwrap this, I guess. Boom. And then we just do that for all of these. I'm a ChatGPT and other tools are like over enthusiastic junior devs who would rather make stuff up than say I don't know. That's how it seems to me. And also, yeah, it seems like the lack of like correctness really bothers me. But like I have found it. I've tried it for like parsing chunks of code that I've written. It seems like reasonably okay at that. But yeah, I guess it depends. I'm sure they'll get better. I'm sure they will get better. Okay, so each of these guys is just going to try to deserialize themselves. Oh, actually the seal is wrong. I think it's more like we want to say cursor state is equal to cursor state from snapshot. Yes. And we pass in the data. I like this. And so now these guys can own their own deserialization as well, which is great. So function from snapshot takes in self. No, he takes in a snapshot, which implements deserialize. Deserialize owned. No? I think. Maybe yes. We'll find out. I think that's the easier one to use. maybe we'll just try deserialize here. Impl deserialize. Okay. And he returns a cursor state. And all he does is he says, how the fuck does serde deserialize work? Deserialize. Serde. I'm missing a step here for sure. I'm definitely missing a piece of the pie. Function deserialize that returns self, where D is a deserializer. Okay, and so what does like the value implement? He implements deserialize for value. Oh, I guess what isn't really what I want. I want like, they have this like from value thing where T is anything that is deserialized owned, like myself, and I take it from this value. But I don't really want it to know that it's like a value here. Like, is there like a, what else does like, does value import, like implement some sort of like generic trait that I can use this way? Into deserializer. Ah, that sounds right. Into deserializer, which returns a deserializer, and the deserializer will let me construct my thing, maybe? Yes, that looks right, because I pass in the deserializer. Lights, thanks for the sub. Appreciate it. So this guy is going to be what? Impl into deserializer, which is gross, but then we can say snapshot into deserializer. Okay, and we can say cursor state deserialize this thing. And I think this gives me back what I want. I don't really know. I don't really know. Expected named lifetime parameter. Why? I mean, we can add one, but I don't really know what it wants from that. Are we close? Recording path doesn't have a size, not a compile time, so that's at 410. This guy needs to put a little ampersand in front. This guy expected option, found cursor state. Sure, so we just have to put a little somebody in front of him. And the trait into deserializer is not implemented for serde JSON value. I thought it was. Am I stupid? The trait into deserializer is not implemented. The for value. But value implements into deserialize. The fuck? What the fuck? I'm missing something. I could just propagate the serde JSON thing around, but I'd rather not like bake that in, right? Like, you know, it's kind of nicer if like these guys don't know that we're serializing as JSON. That would just be nicer. Oh, and then there's some things that don't implement serialize and deserialize. Great. So here we can look at terminal. Terminal color has to be serializable and deserializable. Okay. What else is complaining? 268. So here I forgot to put I put an extra ampersand that I didn't need. That kind of fucks it up. And now we're back on this guy. So like I feel mental. So he is into deserializer de-error for value. Like why does he not think that exists? Is it something? Well, we'll start with commenting this out. And we'll say data into deserializer. Okay, and what does this return? this returns a thing of value. And then value implements deserialize. Oh, so this just does fucking nothing. This goes from value to value. Okay, so this is nothing. So maybe I'm using the wrong type here. This shouldn't be, maybe this should be impl deserialize owned. Which we can import from here. Which doesn't need generics anymore. And then I can just say, please deserialize the snapshot. Which he doesn't like either. What is he complaining about? So he's saying because I don't implement deserialize. So what does like this deserialized owned trait do? Deserialize owned. I've never programmed. I'm terrible at math. Can I learn Rust as first language? And would you have any tips for someone who's never studied at school to learn mathematics at a level good enough to become a decent programmer? Okay, so I think you don't really need math. Well, I shouldn't say that. The like level of math you need to do like the vast majority of programming is like addition and multiplication and division. Division is pretty important, right? But like any math that you learned in like grade 4 is like a lot, like most of what you need. In terms of like first programming language, I don't really have like good advice for that because I'm like so deep in the sauce that I kind of like forget what it was like to be new, right? Because like I started programming when I was like young teens. Justin Nutt says Python. That's kind of like my inkling as well. There's like I think every language has like quirks that you'll have to get around. But I do think Python's probably a good like pick up and go language. I think if you start with Rust, you're going to like hate it. Like I think like starting with Rust will make you not want to program anymore. Where starting with like Python, I think that's a pretty reasonable sane first language. It'll like Python provides a lot of value like for little investment, which is like what you need when you get going. The other one that people I think often start on is like web development stuff. The nice thing about like doing like web dev to start up is that like you have like visual feedback almost immediately. The bad thing about like web dev stuff is like the community around web development is so complex that you might just get kind of lost at like how the fuck do I start? Or I think if you Google like how do I start writing Python, like I think that you'll probably get something that's like pretty sane. And if you start like how do I write a website, you'll be like I hate everyone is like probably. So yeah, I think Python's probably like a good first guess. That would be what I would do. Deserialize owned is a data structure that can be deserialized without borrowing any data from the deserializer. So that's not what I want. I want a deserializer. That's what I want. So that I can construct the thing. Okay, so let's try that. We'll go back here. And this guy says impl deserialize. Like this. And so then I deserialize a snapshot. Okay. Not to say I've never programmed. I've been a front-end developer for 5 years, but I consider myself terrible. I work with Angular, TypeScript, and such, but would like to restart my brain and learn Rust. Oh, I mean, yeah, sure. I mean, if you're like 5 years in, yeah, you can jump into Rust fine. Like, I think that like, in my mind, all languages are like very similar. Well, I shouldn't say all. All the imperative ones are very similar. Like the Lisps and the like Haskells of the world are like a lot harder. Well, I shouldn't say harder. I just like don't have less experience there, and like I think the way you have to think is different. But like you go from like JavaScript to C# to Python to Java to Rust to C to C++. They all have like their quirks, but they're all like kind of like fundamentally that like similar. I'm doing an internship with Pascal. Dude, I've never written Pascal, but it seems fun. Pascal, of course I'm not gonna get anything here. Language. And I also think that like if you want to try stuff, like just fucking try it, right? And if you'll learn pretty quick just by like putting yourself in the deep end. That's like that's my advice. But everyone works differently, so. Oh, oops! I didn't want impl deserialize. I wanted impl deserializer. Of course. Is this the one that gets us? I think that was it. Okay, sick. So we now can get this thing from a snapshot. And so now we just have to do the same thing for all of these. So this guy's going to say format tracker from snapshot data. Nice. This guy's going to say terminal buffer from snapshot data. Okay, and this guy is going to say parser is going to be ANSI parser from snapshot data. Now, all of these guys own themselves. Everyone is chilling. Everything is truly a derivation of brainfuck. Is that as wrong as it sounds like it is? I think it might be like maybe a little bit true, right? Brainfuck is like kind of like the most pure form of Turing machine, and like every language is like kind of a Turing machine. Like maybe that seems pretty wrong, but I also like I can like twist my brain into thinking that it's not that wrong. Okay, so we're saying from snapshot, and we have to copy that same fucking signature from the other thing. This cursor state, we figured out the signature that we need here. It's this. And he's not going to return a cursor state, he's going to return an ANSI parser. And he's just going to say ANSI parser inner is equal to ANSI parser inner deserialize snapshot. Unwrap. All right. This guy needs to import deserializer. So here we need de deserializer. Boom, 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 boom. And now we're chilling. It needs to be public. And we're so close. We are so close. Dude, there's so much code. I keep getting lost. Okay. Terminal buffer. Same treatment. So I guess we'll split. We'll copy this function. We'll go into terminal buffer. We'll put the same fucking function. And this guy does not return an ANSI parser. He returns a terminal buffer. And he comes from himself. Boom, 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 boom. And this guy also needs deserializer. Womp, womp, womp. Easy. Easy peasy. Couple more. Format checker. I keep forgetting. We copy this. We paste it here. We say this guy returns a format checker. And he deserializes. He says let color info is equal to vec format tag. Is this right? Is that like is this syntax that you can write? And then you just say return format tracker of the color info. Easy. We need to import deserializer. Chillin', chillin', chillin'. Comparison operators just need to be like turbofish. No function, name deserialize. How the fuck do you do this? Right, we have like deserialize for vec anything. How do I do like vec format tag as deserialize or something? I feel like I'm missing. How do you like call this thing? Deserialize Rust call trait. Is it just like deserialize like this? And I say this guy's a vec format tag. I feel like I'm missing something. The trait deserialize is not implemented for format tag. Oh, okay. So I just shove that in here and here. Chillin'. And then I think this guy just needs to be public. He is. So what's he complaining about? Mostly fine. Okay. So these guys are all chilling. Cargo check. How broken are we? Only a little bit broken. Sick. Okay, so if we set window size, we're going to have to do something to our terminal emulator. We're going to have to call like terminal emulator set win size with width and height. So we actually kind of have to like take all of the snapshots out first, construct our terminal emulator, then apply the other things to it. I think that makes sense. So we can say recording filter iter filter, and we say item, and we say matches recording item snapshot item. So we will only take snapshot items. And I guess it's the other way around, item and recording item snapshot like this. Okay, is that right? Let's look at the documentation for matches. It takes in the item, then the format thing, yeah. So, cool. And so these guys will just say unreachable. Okay. Then we can construct our terminal emulator and we can iterate again after for the other things. So the other ones. And we do a similar match item thing, but we only care about these ones now. Womp womp, and then we say self terminal emulator set win size width height, and here we say write data or something. Nope, that's wrong. This is unimplemented. We don't know how to do this yet. This is going to be complicated. This is going to require some refactoring, and anything, the recording item snapshot is unreachable. Okay. And then we just need to like, how do we like construct the terminal emulator now? It's going to look something like this. So let mute terminal emulator is equal to this. And the parser is going to be parser unwrap. Terminal buffer is going to be terminal buffer unwrap. Format tracker is going to be format tracker unwrap. Okay, decum mode is going to be decum mode unwrap. Cursor state is cursor state dot unwrap. Chilling. Recorder is going to be a new recorder. And now we just have to figure out how to like deal with this, the fact that it is expecting a file descriptor. Okay. What if, just hear me out, for now, we just spawn a shell anyways. All right, we're hacking, okay? We're hacking. It's fine. Fix me, don't spawn a shell in recording mode. But we're just hacking. We just want to know, right? Unwrap. Okay. Yep, okay, so this guy has to come first. This guy comes here. This guy needs a semicolon. This guy needs an unwrap. And this guy needs an unwrap. Okay. Okay, so now we have our terminal emulator, and we can do this. And the last piece here is you need to figure out how to push the data in if it doesn't come from a file descriptor, which seems like it should just be function handle incoming data, right? And the data is just like this, data U8. And then we just take all of this code, Yeah, I guess it's all of this. And we put it in here. Well, and then we just call that here instead. Incoming. What are you making a replay system for? So I want to be able to capture a bug in my terminal emulator and like slowly debug it step by step. So we are like writing down all of the inputs to our terminal emulator and then trying to replay them by opening the recording. Okay. So this guy just has to be called, we'll call it incoming here for naming consistency. And so now we should be able to say that if we get data here, we can just say terminal emulator dot handle incoming data of the data. Boom. And then we just return the terminal emulator. Okay, so if we did everything right, which certainly we didn't, we should be able to open the recording now instead of construct a new terminal emulator. So let's hack it up a little bit. And for now, we're just going to say we're going to construct a terminal emulator from a recording manually. So we're going to say terminal emulator from recording, and we're just going to say that the recording is recordings 4. And we'll see if this works. It might. He doesn't like that because this guy needs to call into path new, maybe? Use stood path. And so if we did everything right, we should see that like git log that we recorded before replayed. And we didn't because everything sucks. Okay, hold on. I think that we missed the cursor state in that one is probably what that unwrap was complaining about. I think that we forgot to record some of the data last time. So we can just look at terminal emulator 464. And he is complaining that the cursor state wasn't written down. So I think we just need to re-record the same thing. We'll just make a new recording. It's fine. It's fine. Okay. So let's do the same thing where we type, increase the font size a little. We say git log. We maybe expand this a little bit. Go down, up. And what are we going to do? We are going to start a recording. Hit down, down, down. Stop the recording. And we're going to screenshot this. Save. And try to make sure that we get the same thing. Okay. Cargo. So now we go back to main. And we construct from the recording instead. And we say let's record from recording 6. And let's see what we see. Ah. Fuck. Okay, so that's pretty damn close. I think. I'll bet I think this is close, except that we need to like match the font sizes here and stuff, which is going to be a little bit of a pain in the ass. So our GUI now has to support. He kind of needs to know that he's in replay mode. That's what he's going to know. Okay, so we can kind of say that we implemented reload of terminal emulator state. We've kind of implemented that. But now we need to implement like GUI support for recorded mode. And we kind of hacked of a bunch of the stuff in here as well, right? Like this guy still has a file descriptor, which is causing problems. So I think we're going to have to like maybe make some sort of like, how do I want to handle that? Sorry, I'm just thinking. Okay. I think all we need, we can get pretty, we can get creative here. So I think we will need to implement like a trait that is like our input output with like the terminal system underneath the hood. And so our terminal emulator will like have some sort of terminal state associated with him. And he'll be in charge of things like set window size. When that like calls an ioctl, that will go through that trait. Maybe. It'll be something like terminal emulator will have a IO system who will have like set win size, write, and read. And depending on our implementation, this might go and this might call this could call the like ioctl to set the size, or it might just like reject the write altogether. Like if we're playing from recording, we should say fuck you, no, we will not allow a resize. And like same with the write call, we'll just say fuck you, no, we're not going to do anything. And then on read, we'll just read from the recording. And I think that if we implemented this, then the GUI would start to work for free. Yeah, I think that'll work. But we are at the 2-hour mark. So I think it makes sense to call it here for today and finish this up tomorrow. This is a pretty fun little experiment. And you can see we're like pretty close, right? Like the fact that we have something that resembles a git log in here is pretty reasonable. Oh, you know what? Actually, I'll bet if we do something that's less interactive, it'll make more sense. Let's try that. But just one more thing before we go. So let's go back to main and let's try to make a recording of, we won't resize the terminal at all. Okay. We'll just say pager equals cat git log. Okay. And that'll print something. Oh, fuck. I forgot to record. Clear. Start recording. So you can say pager equals cat git log. Stop recording. And so let's try loading that recording. That was recording 7. And since we didn't change the terminal size or anything like that, we should get something that resembles that, right? Here's our scroll back. Pager equals cat git log. And here's the log. We're very close, right? We've like recorded the data and it's like being replayed successfully, which is like a very good sign. The only piece of it is we have to like polish it up and make it look a little, like make it more usable and like add a timeline in here so we can scrub through and like replay from different sections. So I think that's enough stuff that we're going to have to spend another couple hours on this tomorrow. But I'm happy with the progress we made today. That's like, that's really good progress, right? We got a lot done. Yeah. So if you like what we saw, I stream most days at around 1 or 2 o'clock Pacific time for like 1 or 2 hours. VODs go up to YouTube, and there's a YouTube link in the Twitch description. There's a GitHub link in the Twitch description. So if you want to see the code associated with this project, it's actually for like the first time in a long time, it's like all the way up to date. So, up till yesterday, I spent some time last night getting everything in. So we're in a pretty good spot there. If you're watching on YouTube, there's a Twitch link in the YouTube description, and you should swing by and say hi. Apologize to chatters today. I was not paying enough attention to chat because my head hurt, and you guys were talking a lot. But, you know, if you swing by from YouTube, you can contribute to my confusion. Yeah, I think that's it. Thanks, guys. I'm going to catch you on the next one. Bye!